When solving a problem in physics that has math, we have a few steps that I would suggest you always do. So here's our problem. A car is traveling down the road at a rate of 35 meters per second. This is about 70 miles an hour. It slows down to a stop, traveling a distance of 100 meters. What is the acceleration of the car? And so step one is always to draw a picture. The reason we do this is so that you can determine which way is positive. So I'm going to draw my car here. It's traveling down the road, and then it stops here 100 meters later. So this is going to be 0 meters to start, and it's going to slow down. This automatically tells me that this is the positive direction because that's increasing numbers. I could have said that it started at a position of 100 meters and then stopped at 0. Like, you could have done that. That would have been weird, but sure. Draw a picture, and which way is positive? Then the next step is to list all your variables. When working with problems in one dimension, so just things going back and forth, we only have to worry about 6 variables. That's our initial position, our final position, our initial velocity, our final velocity, the acceleration, and the time. So I list all 6 of these, and then I start writing down the things that I know. All right, my initial position, 0 meters. Because this says it slows down to a stop after traveling in a distance or a distance of 100 meters, I know that 100 meters is my final position. A car is traveling down the road at a rate of 35 meters per second. This seems important, 35 meters per second. Use the units to cue you because meters per second is a unit of velocity. So it seems like this is the initial speed that it's going. So I'm going to call this my initial velocity. Notice how I'm annotating the problem as well as writing in the numbers into here. So if it slows down to a stop, stopping is important. When something stops, you're not moving anymore. So when you're not moving, that means your velocity is 0 meters per second. So it was moving, now it's not. That means our final velocity is 0 meters per second. In this question, it's asking what is the acceleration of the car? And so that's, I don't know that. I'm going to put a question mark there. Nowhere in this problem does it tell me about time either. So I'm going to put a question mark at time. And the next thing, list your variables. What are you looking for? Like, identify what you want. Step 4 is going to be pick an equation. Okay, so what am I looking for? I'm looking for what is the acceleration. So I'm looking for A. I always circle the thing that I'm looking for so that I don't get lost and solve for something else. And this pick an equation piece. So now you need to go back to those kinematic equations and decide which one's the one that you want to use. So we get this one, velocity final is velocity initial plus acceleration times the time. We get my favorite, change in position is the initial velocity times time plus 1/2 acceleration times squared. And then you get this crazy one, the final velocity squared is the initial velocity squared plus 2 times the acceleration times the change in position. So this whole idea of picking an equation, you need to pick an equation for which you have the thing you're looking for, right? So I'm looking for A. I'm looking for the acceleration, so I need to pick an equation that has acceleration, so all of these do. But I need to make sure I pick the equation that has what I'm looking for and doesn't have anything that I don't know. And so when I look at this, I don't know the time, and I need an equation then that does not contain the time. So even though this first equation and the second equation have acceleration, they both contain time. If I don't know that, I can't use it to solve for the acceleration. And so this third one, this funky one, This is the equation that you'll use every single instance that you don't know the time and you're looking for something else. And so I'm going to write my new equation up here. Velocity final is velocity initial squared plus 2 acceleration delta x. At this point, it becomes a plug and chug. So you can manipulate this. You can solve for A as is. You can solve for the acceleration as it is with letters, or you can plug your numbers in. For this class, I am not actually going to be pressed about you solving out the math piece of it. I'm more interested in making sure that you put your variables in and they all have the correct sign to them. So they have all the right units and they have the correct positive and negative. So plug numbers in and 6 will be solved. Okay, so when I plug my numbers in, my final velocity is 0 meters per second squared equals my initial velocity, 35 meters per second squared, plus 2 times the acceleration times the change in position. Remember this change in position, delta x? That's from a long time ago. Delta x is the final position minus the initial position. Okay, so I'm going to go 100 meters minus 0 meters. Most of the time, this is where I'll have you stop. I'm going to go ahead and plug this in and see what we come out with. Units do weird things when they're when you do math with them. So this is going to be 0 squared is 0, but you're going to end up with meters squared over second squared. And this is going to be 1225 meters squared over second squared plus 2. And I'm going to switch this around times 100 meters times my acceleration. This goes to the side, so I get negative 1225 meters squared over second squared equals 200 meters. I'm going to put that in parentheses so this m doesn't get confused with my a for acceleration. Divide both sides by 200 meters. Notice how I have a meter squared up top here and a meters down here, so this meter will cancel with one of those meters, and my acceleration is negative. I'm just wondering if that makes sense, right? It's important that the numbers we come out with make sense, and so if you think about it, it was traveling in the positive direction. It's slowing down, so if its velocity is positive and it's slowing down, that means the acceleration will have the opposite sign. It should be negative. So it makes sense that my acceleration is negative. I do this division and I get 6 let's just call it 1 meters per second squared, which is my actual value for the acceleration. That's pretty fast, but that's the way it is.